so thanks everybody for coming up on the last half of the day, so I'll try to finish up as fast as possible. Alright, so my name is Aly Sivji. You can find me on Twitter. I am at Sivji. I live in the south side of Chicago, and I work at a healthcare startup called Jasper Health. We're building a patient monitoring solution in the cancer management space. We just raised a huge Series A round and are hiring US-based engineers. Come by me after if you'd like to do a lot. I also help organize the Chicago Python community group. We call ourselves ChiPy. ChiPy is one of the largest Python communities in the world. We have over 6,000 members. We're actually back to being in person in February. Awesome, yeah, thank you so much. So if you're ever in Chicago, please come on down. More info is on our website. We also live stream our events, so if you want to find out more information, check out chiPy.org. This is my agenda slide. I don't really look at this slide, so I'm not going to go over it, but I think we'll care. Let's just get started. I titled this talk Everyday Design Patterns because I really wanted to emphasize that we don't need to be designing complex distributed systems to take advantage of design patterns. We can use them in our everyday code. So what are design patterns? Design patterns are solutions to commonly occurring problems in software design.
When you can think of design patterns as customizable blueprints that you can use to implement a solution to a known problem. And when you use a pattern, you don't really use the pattern the way it's described. You really need to adapt it to what your project's trying to do or what your specific use case is trying to do. And there are many benefits of using design patterns. Design patterns are tried and tested solutions to commonly occurring problems in software design. Design patterns are not really specific to any one domain or application area. In design patterns, they make our code reusable. We can extract functionality and use it somewhere else. And finally, design patterns give you a shared vocabulary we can use with other developers. And this is really, really important. Once we have a shared vocabulary, we can communicate with other developers. Common language elevates the way we talk about architecture. We can focus on higher level abstractions versus focusing on low level details. I really wouldn't be giving a full picture of design patterns if I didn't talk about some of the criticisms. Design patterns, they're considered workarounds for the limitation of a programming language. For example, in Java, there are design patterns to mimic features such as multiple inheritance or decorators. Languages such as Python have these features built into the language. And if we always rely on design patterns without thinking of the larger picture of our application, it could really lead us to design inefficient solutions with many layers of an inheritance hierarchy. And finally, as programmers, we have a tendency to try to solve the problem with the newest thing that we learned. Design patterns are great, but they're not a holy grail. You really need to understand how to use them properly. While there are hundreds of design patterns out there, we're going to be focusing on a single pattern. Unsurprisingly, we're going to be diving deep into the observer pattern, and we're going to see how we can use the observer pattern to write loosely coupled code that is easier to understand. The observer pattern defines a one-to-many dependency between our objects. If one object changes or performs an action, all of its dependencies are going to be notified. I think this concept is best demonstrated with an example. So let's say we have a newsletter that people can subscribe to. Users can subscribe to a weekly newsletter, a daily newsletter, or they can subscribe to both. User 1 comes along and they subscribe to our newsletter with a weekly frequency. User 2 comes along and they subscribe to both of our daily and our weekly newsletter. And finally, user 3 subscribes to our newsletter with a daily frequency. Okay, that's great. We got 3 active subscriptions, and all of these people are waiting for our emails. Now say we're at the end of the day, it's time to send our daily email. Our editor writes it up, and they click the send button. This newsletter, it's only going to go to our daily subscribers. In this case, it's going to be user 2 and user 3. And when we send our weekly newsletter, it goes to user 1 and it goes to user 2. All of this, it really makes sense. Like, all the people that subscribed are going to get them as they expect. After a couple months, user 1 realizes that the content we sent is not that great, so they're going to unsubscribe. And now we only have 2 active users. And the next time we send a weekly email, it's only going to go to user 2 since they're the only active user. So this toy example, it demonstrates a few key points. We have a relationship that's one to many. So we have one newsletter, many different types of subscribers. Subscribers can also subscribe to different event types. So we can subscribe to our daily newsletter, our weekly newsletter, or both. Users can also unsubscribe. And note that these things are business requirements. We might have other cases where limitations are we won't let people unsubscribe, or users can only subscribe to one type of newsletter. And then finally, when an event occurs, all subscribers are going to be notified. The payload can include extra information about the event for the subscriber. So in our case, when we send an email notification, we're probably going to include our newsletter in our email body. But really, this could be any data that subscribers can use to perform their task. And finally, the point of doing all of this is that publishers and subscribers can change independently. When we're talking in software design speak, we say that these components are decoupled. So if a subscriber wants to change their email application from Gmail to Outlook, the publisher doesn't really care as long as their email address stays the same. As I mentioned, one of the big benefits of design patterns is that we define a common language for more effective communication. So let's take a step back and have the same discussion in the domain of design patterns and design pattern terminology. So let's go through that definition one more time. The observer pattern defines a one-to-many relationship between our objects. If one object changes or performs an action, all of its dependencies are going to get notified. So going back to that example, we have a single newsletter publisher, we have many different subscribers, or if we're talking about things in design pattern terminology, we have a single subject and many different observers. Observers can register with the subject to receive notifications. Observers can also unregister. And when a subject changes, all of its registered observers are going to be sent a notification. And so what are some real-world use cases where we use the observer pattern? And note the cases I'm going to talk about, they're probably going to have some hardware or some software that's going to be handling the message bus layer, but really under all that complexity is just the observer pattern. So when you book a ride on Uber, you're going to be subscribed to all the notifications for that particular ride. And when a driver is downstairs, they're going to send a message to the Uber server. The Uber server is going to send us a push notification that lets us know the driver's downstairs. When you buy something on Amazon, you're going to be subscribed to all of the notifications for a particular order. And then when your package ships, if it goes in multiple parts, you're going to be receiving an email with a tracking number. Basically, any kind of notification system, it's going to be using the observer pattern underneath the hood. And finally, the observer pattern is widely used in HTML and JavaScript. We can add event listeners to DOM elements to have user interaction. Now that we have a sense of the observer pattern and how we can use it, let's take a look at various open source implementations of this pattern. Digging into open source code, or really anybody's, like other people's code, it's going to help us understand how other people solve the problem, and hopefully we can use this knowledge to make our code just a little bit better. So the first example I'm going to talk about is the observer pattern that is in the Python standard library logger. Real quick overview of the Python logger. Logger is a singleton. We have one instance that we access globally. And if we want to configure our logger, we have a formatter, which sets what the log looks like. We have a handler, which lets us set where our log is going to be going. And we have a logger, which allows us to assign handlers to various different namespaces. And then we want to select a logger. We can use logging.getLogger to actually get the logger and perform whatever we would need to do. And so this is a configuration of Python logger using a dictionary. We'll walk through it really quickly. So first we set up a formatter. We call it standard, and that's just going to be letting us set our log fields. We're also going to be setting up two log handlers. So the first handler, it's going to be sending all of our logs to a file if they are of the level debug or higher. And the second handler, it's going to be sending all error and critical logs to standard error. And then finally, when we create a logger in our root namespace with these two handlers, and we say that this logger is going to be triggered if log events are of debug or higher. And just to note that if we don't specify the logger namespace, it's just going to default to the root namespace in this configuration. So now in our application code, we can import logging, load our configuration, fetch a logger. And then we're going to add some application logs. And these log events, they're going to get sent to log handlers and get processed as needed. So going back to that file handler, it's going to capture all of our logs in that spam.log file. And then the console handler is going to capture logs that are error or critical, and it gets sent to standard error, which is pretty standard for logging. So relating all of this back to the observer pattern, we have that one-to-many relationship. We have one log event. It can be processed by many different handlers. And when we set up the Python logger, we register handlers with our logger. We're going to add log statements to our application. These statements are going to generate a log event. And then these log events are going to get passed to the handler. And the log is going to be emitted if the log record level is greater than our handler threshold. And the key benefit of using this pattern is that it allows us to have our application code separated from our logger code. The next implementation of the observer pattern is in Flask. It's the URL router. And so for those that don't know, Flask is a framework that routes client requests to different handler functions. And this is a canonical example I pulled from Flask's Quick Start. We can use decorators to register view functions for different URL paths. And as we register these routes, Flask is going to be building a routing table behind the scenes. And this is the routing table for the web application on the left side. And so when Flask gets a web request, it's going to use its internal routing table, and it's going to route that request to the appropriate handler. So going back to the observer pattern, how does this fit in? Again, we have that one-to-many relationship. There's one request. We have many different route handlers. And looking at the Flask routing workflow, we use Flask helpers to help us register different URLs. And note that we're going to have one handler for every path verb tuple. And this is a business rule that's been encoded into Flask. So when Flask loads up and it sees a bunch of different route handlers, it's going to load the last one registered for a particular pair of path as well as verb. And then when Flask starts, it's going to be building a routing table. And then when a request comes in, it's going to be forwarded to the appropriate function. And once that function is done, we're going to send a response back to our client. And using this pattern, it allows us to decouple our web framework logic from our route handling logic. And they allow those things to change independently. Like, we don't need to update Flask in order to build a web app. Another implementation of the observer pattern can be found in PyTest's plugin manager. PyTest, it's built on top of a hook-based plugin system. And what a hook does is it identifies different points in your application where the application can be extended. And when PyTest first loads up, it's going to load all of our plugins, and it's going to register those plugins for various hook functions. And then when a hook is triggered as PyTest is going through its runtime, all of the registered functions for a particular hook, they're going to get notified. And in particular, for PyTest, these functions are going to be passed a context payload, and then our functions can view, use, modify, pass back these payloads as they need. And a fun fact, PyTest doesn't really have a lot of logic. It's built on top of a plugin system called Pluggy. And a lot of PyTest's core functionality, it's implemented as a plugin, which is like pretty cool. It's the observer pattern on steroids. And so there are many different types of PyTest hooks we can use to customize our behavior. In the plugin example I'm going to show, we're going to add a flag called skip slow to the PyTest CLI. And this command is going to help us skip slow tests. Notice right now this is not working. We're still running 2 tests. So to first write this plugin, we're going to have to open up our conftest.py file. We're going to be using PyTest_add option hook to add a new option to the PyTest CLI. And then we'll use the collection modify items hook that's going to be run after the test discovery process. So once PyTest finds all the files and all the tests inside of your files, it's going to be running this hook. And what we're going to do is we're going to skip all tests that we mark as slow. And now when we run our tests, only a single test is going to be run. So bringing things back to the observer pattern, we have that one-to-many relationship. There's one plugin manager, many different types of plugins. And then when PyTest is started, all of our plugins are registered and loaded. And as PyTest runs, hooks are triggered, and all the registered plugins for a given hook, they're going to be notified and sent a context payload. And so the main benefit of using the observer pattern is that PyTest and PyTest plugins are decoupled, and that's exactly what we want when we're designing a plugin system. And the last implementation I sort of want to walk through is the observer pattern that's built into Node.js. And this is actually how I first learned about the observer pattern. I saw somebody using an event emitter, and I thought it was a really great pattern that I wanted to port into Python. And so really quickly, for those that don't know, Node.js is a JavaScript runtime that allows us to use JavaScript outside of a browser. And as we saw earlier, client-side JavaScript, it handles user interactions with event listeners. And with the event emitter, we use that same design principle for backend Node code. So the easiest way to understand it is with an example. I know we're at a Python conference, but bear with me, we got some JavaScript. So we're going to import the event emitter. We're going to create a new instance. Next, we'll register 3 event handler callbacks. That's sort of just the function and the syntax for that. 2 of them are going to be handling the start event, and the last one is going to handle a stop event. And then finally, we're going to emit a start event. And then when we run this script, we're only going to be running callback functions for the start handlers, which makes sense. So how does the event emitter implement the observer pattern? We have a one-to-many relationship. There's one event, many different event handler callback functions. And to use an event emitter, we're going to first create an instance. We're going to register all of our callback functions for different event types. And then when an event occurs, all those callback functions for that particular event type, they're going to be run. And the main benefit of this is it allows us to decouple our event parsing logic with our event handler logic. And I do want to make everybody aware that there's already a Python port of the event emitter. It's called PyEE. And it's actually a decorator-based event emitter, which can be used synchronously, or you can plug it into any of the async event loops. And I think that's pretty awesome. Like, if you're doing async in Python, this is a really good pattern to start learning about. And so looking at all of these implementations of the observer pattern, we did notice some common themes. First, there is that one-to-many relationship. And every time we run our code, we're registering events with a specific handler. And then when that event is triggered, we're going to be notifying all of our handlers. And the main benefit of doing all of this is it allows us to decouple our code so they can be changed independently. And that's the big thing. And I really want to show all of these examples to illustrate that the observer pattern is not a one-size-fits-all solution. Each of these implementations, it's solving a different problem. And as we saw in the Flask case, we're actually able to codify business rules inside of our observer pattern implementation, which is pretty awesome. So that was a lot of theory. Let's roll up our sleeves and write some code. And in this example, we're going to be implementing a Slack bot using the observer pattern. So really quickly, Slack is a chat platform. We can use the Slack API to build applications, or bots, if you want to call them that, and we can use them to interact with our users or to automate different types of workflows. One way we can interact with our application or with our bot is using a slash command. And when we submit a slash command to Slack, it's going to cause a payload to be sent from Slack to our command webhook, and then we can process the command and return a response. So going back to this command, by clicking this send button, we're going to be causing Slack to send a HTTP request to this webhook URL, and the request is going to be a post request, and the body is all form encoded parameters. But really, a lot of the data there is metadata that we don't care about. The things that we care about for this application are the command and the text field. So for our MVP, we're going to create a bot that responds to the slash observer command. And this command is going to handle 3 different subcommands. If we do slash observer time, it's going to give the current time, slash observer date, current date, and then slash observer echo and some text. It's going to return that text to our Slack instance. So for our first attempt, let's keep things simple. We're going to inline all of our command handlers. So we'll start with some Flask Boilerplate to handle any request. We're going to parse the request body that we saw a little bit earlier. And now we can write up handler code for each of our slash commands that we're going to handle, and we're done. I think this is a really good start. By inlining our initial solution, we can get up and running really quickly and start iterating on a better product. But as our program grows and as we start to handle more commands, or if the logic in these command handlers gets more complex, you can start to see that this inline approach, it's going to get a little bit more complicated. So if we ever find ourselves writing a series of complex if-else conditionals, it indicates that there might be a better way of doing things. And just because there is a better way of doing things doesn't mean we have to go out and refactor. It's just something we have to keep in the back of our mind as our program scope grows. I should even talk about this called if statements or code smell at PyCon, so check that out if you want to learn more. But since this talk is about the observer pattern, we're going to refactor our implementation to use a decorator-based event emitter. And so before we do that, let's make sure that the observer pattern is the one we actually want to use. So first of all, we see that one-to-many relationship. That's the big key. Hope that's coming across. We have one slash command, many different command handlers. And we want to register handlers for a particular command. And for our specific use case, we only need to register commands. We don't really care too much about unregistering. And another business rule I want to add to this implementation is that each command is going to have one and only one handler function. And finally, when a command is received, we want its handler function to be executed. So let's start with that Flask boilerplate from before. The first refactor we're going to do is we're going to move each of those command handlers into its own function. Next, we're going to create an instance of the event emitter, and we're going to use a decorator to register different handlers for different commands. And then finally, we have to write some code in terms of parsing the request and emitting an event, so just connecting some dots here. And I do want folks to notice that we have a default command inside of the emitter emit event. And so what this does is if we enter in a command that's not inside of any of those handlers, it's going to improve our user interface. It's going to be returning an unknown command message to Slack. I'm not going to be walking through this code, but I did want to show everybody the code for my event emitter. All this is on GitHub, so you can check it out later. So this is something I actually just implemented myself. I didn't use PyPI. This is not really complex. I think it's 17 or 20 lines. And it also allowed me to hard code some business rules inside of my class. So in this case, if we have an event that has more than one handler function, we're going to be raising a custom exception that I made. So let's take some time. What do we do here? I'm going to be the first one to admit that the observer pattern implementation is a lot more complex. But we really need to start thinking about, is this increased complexity worth it in a cost-benefit analysis? So what are some of the benefits of using the observer pattern? So the main benefit we have is that we're able to decouple our event parsing logic with our event handling logic. And by having these individual handler functions, things are a lot easier to understand, and they're going to be definitely a lot easier to test. And one big point I did want to note is we implemented the observer pattern with just pure functions. Traditionally, when we're using this pattern, it's written using an object-oriented approach, which I did provide links for. But I went with functions in this example since functions are a lot easier to understand. We have an input, we do something, we have output, and we don't really have to worry about internal state, which is a lot nicer. And I think decorators are a great way to register functions at runtime. And the final thing I want to cover is the observer pattern versus PubSub. And so you might be familiar with PubSub if you were here for the talk this morning, definitely with Kafka. And so there are frameworks like Kafka, products like Amazon Kinesis. And recall when we're doing the observer pattern, this is our high-level diagram. We have one subject. We have many different observers. This is a diagram for PubSub. For PubSub, we have one publisher and many different subscribers. And in the middle, there's going to be a message broker. And this is going to handle all of our message routing. So when the publisher first starts up, connects with the broker, it lets the broker know what topic or what stream it wants to publish to. And then when observers come online, they're going to register with the broker to receive all of those messages for a particular topic or a particular stream. And if the publisher changes or performs an action, it's going to send a message to the broker, which is then going to send the message to all of the subscribers for that particular topic. And also note that PubSub, it's gonna allow us to have many different publishers. The broker is really responsible for handling all the complexity related to the message bus. This is a little bit more complex, but underneath all of it, it's really just the observer pattern. So let's recap. The observer pattern is a design pattern that defines a one-to-many dependency between our objects. If one object changes or performs an action, all of its dependencies are going to be notified. We walk through various open source implementations of the observer pattern. And the main takeaway I want people to have for this talk is, next time you see a pattern in a particular library, a framework, or a language, figure out like why you like it. Take a look at the underlying implementation. Find out what's going on. Chances are you're going to find a tried and tested design pattern that's going to make this particular tool easier to work with. And learning about all these different patterns and learning about their trade-offs is going to help us write better code on an everyday basis. And so these are all the resources I used to come up with this talk. If you're new to design patterns, I really recommend the first book. It's called Head First Design Patterns. It's a really great introduction. They have like pictures. They explain things in a great way. Love that book. That's it for me. Thanks so much for your time. But before I go, I do want to give a shout out to Chicago Python. Would not be where I am without that fantastic organization. Thanks for your time. My name is Aly Sivji. I'll take your questions. No questions? All right, yes? So the question was, is PubSub truly is an observer pattern since it's not really a one-to-many, but it's a many-to-many? I sort of think the one-to-many is more like, it's the many that really matters, not sort of the one. And so I would sort of say it's not technically an observer pattern, but it has a lot of the same types of characteristics. Anybody else? All right, I'm going to be at the after. Yeah, go ahead.
So this observer pattern, I always think of it as happening within a code base where you have the events being published within a given code base, and you have another. But in a PubSub environment like you just described, it's across a distributed infrastructure. So do you envision that the observer pattern would actually be the broker part of that?
Yeah, so the question was like, since like PubSub is across like a distributed architecture, is the observer pattern in the broker? I would sort of say, like, I'd say yes. It's really more of like a higher level way of like looking at it. Like, I wouldn't say PubSub is equal to the observer pattern, but it has a lot of the same characteristics, and knowing about the observer pattern is going to make understanding PubSub a little bit easier. Anybody else? All right, I'm going to be at the after party, so if you have any questions, please find me after. Also, Jasper Health is hiring. Come find me. Thanks so much.